Welcome to my presentation. My topic is Insights for Chicago to Improve Public Safety. Here is the outline of the presentation. So the main objective of this project is to generate actionable insights for policymakers to improve public safety initiatives through data engineering and analytics, and also to identify high-priority geographic areas, highlight contributing factors to crime in Chicago, such as educational level, per capita, and so on. And I have 4 different data sources. The first data source, the first 2 data sources are dynamic, and the other 2 are static. So the dynamic data sources are really large, especially the crime incident. This is about crime reports, and it's about 8.1 million rows, and these are both updated daily. And here's the architecture. So we have 2 different data sources, which would be ingested weekly. First, the historical data will be ingested. So for the sake of simplicity, since I have a lot of data, I just ingested only the last 5 years data from 2019 to current date. So once that is done, every time a new data is available, it will be ingested weekly. And the other data sources, socioeconomic indicators and geospatial data, are very small, so ingested only once and will be saved in the storage account. After ingestion, it will be transformation. The data will be unified, merged, and so on using Azure Databricks. And after that, this cleaned data is used in the for analysis using PowerBI and Jupyter Notebook. And all the code is synced to GitHub repo. And here's also the Azure setup. I have Azure Databricks accessing a storage account using Key Vault. So that's how the workspace is set up. And all the code will be again synced to GitHub repo from Azure Databricks as well. So here's the ingestion consideration. So I used API filters to select only relevant data. So I have a lot of columns, more than 22 columns, and millions of records. So I used the column filter to select only columns that are relevant for my analysis. I also applied a row filter to get specific dates, like since I'm ingesting data sets until 2019, I ingested using that row filter to create batches for a specific year, also to avoid null values and so on. What I learned initially, my chunks were not small enough, so that was one of the big learning points. So to be able to make small chunks that would be ingested successfully without causing any problems, and also to show the progress of ingestion using this good Python library called TQDM. So I also used the paging to avoid throttling. So here's a small image of the website. So I can filter which columns are relevant. So the way I kept all the columns are so that I will be able to join them later on. So what I did was to keep column attributes common to different data sources. So for example, my crimes data has a case number, and my arrest has also a case number. So I kept these attributes so that I will be able to join this data sets later. So this is the ingestion code. So I have API endpoint, and as you can see, I have a row filter, so I can create batches by time. And here is also a column filter. So this is how I kept the specific columns that are relevant for my analysis. So the other consideration is to show, in case if there is no new data, to be able to show some appropriate cases. Otherwise, the code might break. One of the advantages of doing this way is to make sure, like getting only the relevant data, especially avoiding the null values, is saving a lot of effort downstream, like to avoid a lot of data cleaning effort. So as you can see here, the data is ingested in batches. For example, this is for arrest data. This is for 2019, 2020, and so on. And so the transformation step is about, first it's unifying the chunks. So these small chunks of data will be unified into one data set for arrests. And after that, to join these data sets with other groups of data, for example, joining arrest with a crime incident and socioeconomic indicators. Also performed some aggregate calculations. So this is a transformation, and some simpler forms of transformation, like changing the data type or adding some column, was done within the PowerBI. So this is how the data evolved through. So I have different data sources coming through and unified and created one data, and this one also unified. And finally, I joined these 2 and also finally joined, and finally I ended up with a huge, large table, which was used for my analysis in PowerBI as well as in Jupyter Notebook. And here are some of the insights extracted from the Jupyter Notebook. For example, the most common arrest was taken place in a specific police district called District 11, and as you can see, we have most of the arrest cases are happening within this district. And here's also some visualizations from socioeconomic areas. So this map visualized using Folium. So as you can see, for example, in this visualization, District 11 has the most arrest count, and also we can see that the crime incidents are larger in this area, and also this socioeconomic indicators seem to indicate that these disadvantaged areas have a higher rate of poverty. So the socioeconomic indicators seem to positively correlate with arrests. So crime is highly related to those socioeconomic indicators. And here's also some visualizations from Power BI. And as you can see, crime has been higher before 2020, and then it came down a little bit, maybe because of the COVID lockdown. Maybe there was less activity during that time, and then so on. And also we can see the historical aggregation of crime over the months. So it seems like around March there's more crime incidents. And also the other insight is like during the weekends, like Sunday, Saturday, and Friday, there seem to have more crimes and so on. So these are some of the insights. And so these are some of the insights which I got from the analysis. So Police District 11 in Chicago has highest crime rate. Most of the crime incidents happen on the street. Crime rates tend to rise towards the weekend, as I mentioned before. So the most common crimes are related to battery, narcotics, weapons, and theft. So socioeconomic indicators seem to have a positive correlation with the crime. So socioeconomically disadvantaged areas experience more crime. So based on this analysis, the call for action is to allocate more resources for specific districts like District 11, also to allocate more resources towards the weekend. And most crime incidents also happen on the street, so the police must act around that area, also to pay attention to most common types of crime such as battery, drug, guns, and so on. Also to pay attention to socioeconomic disadvantaged areas to reduce crime rates. So due to time limit and constraints, some of the things are not done in this project, which I would like to do in the future to further improve the project, is to automate the ingestion using Azure Data Factory. So right now it's programmatically ingesting and creating those containers and so on, but I want to orchestrate this orchestration tools. And also I want to automate the cloud infrastructure using infrastructure as a code. Also I want to do some unit testing. Thank you for attending my video. If you have any questions, just let me know.